Hi, my name is Jeremy Cotton, and this is my management plan for the Bottomland Horwood property owned by Dr. Suggs. This management plan focuses on balancing ecological restoration with sustainable use of the property. The primary objectives include trophy deer hunting, sustainable forestry, conservation easements, restoring ecosystem function, conservation of appropriate species, understanding ecological indicators, enhancing pollinator diversity, and supporting additional recreational opportunities. This map shows the property boundary and overall layout of the site. The landscape is primarily bottomland hardwood forest with modified hydrology and existing structural features that influence water movement and habitat conditions. The site reflects a bottomland hardwood system with altered hydrology and variation in forest structure. We observe differences in vegetation, water distribution, and habitat complexity across the property. To assess these conditions, we conducted general field assessments, including overstory observations, water control structure surveys, and browse evaluations. One of the biggest factors influencing these conditions is hydrology. The objective is restoring ecosystem function through hydrology. We observed that water control structures vary in type and condition, which creates uneven water distribution and limits habitat quality. As shown in the chart, this variation in structure condition is consistent across multiple locations on the site. We recommend repairing, standardizing, or removing these structures to improve hydraulic function. An alternative option is maintaining and managing existing structures, but this provides less long-term ecological benefit. Forest structure is another key component of habitat quality. We observe variation in snag abundance across the site, with forested areas supporting more structural complexity than more open areas. This figure highlights that some plots have significantly higher snag densities than others, reinforcing that variation. This indicates that some areas provide better wildlife habitat than others. Maintaining and enhancing snag presence is important for supporting biodiversity and ecosystem function. Vegetation patterns also varied across the site. We observed a higher vegetation cover in certain ponds and canal areas while others showed lower levels. The map and graph together show how these differences are especially distributed across the property. These differences suggest that hydrology and connectivity are influencing vegetation distribution. This further reinforces the importance of managing water movement across the property. This chart shows variation in habitat quality across the site. Some areas exhibit stronger ecological condition while others are more limited. These differences help identify which areas may benefit most from targeted management. These differences reflect underlying factors such as hydrology, vegetation, and forest structure. These observed conditions directly guide the management recommendations that follow. Wildlife observations indicate that the site supports a range of species across multiple groups. As shown in the images, species from different ecological groups are present across the site. This reflects the diversity of habitats present and suggests that the system is functioning at a moderate ecological level. Maintaining habitat structure and hydrology will be critical for continuing to support this kind of diversity. The objective is to support a conservation-relevant species. We focus on the prothonothere warbler, which depends on forested wetlands, standing water, and cavity trees. We observe a high habitat suitability across multiple stands, indicating strong potential habitat on site. This is supported by the habitat conditions shown in the data in the figures. We recommend maintaining hydrology, protecting cavity trees, and preserving forest structure. These species also act as ecological indicators, reflecting overall ecosystem condition rather than game species. An alternative species is the Swanson's warbler, which requires dense understory and canopy gaps. To support these species, active forestry management is necessary. The objective is long-term sustainable forestry. We observe variation in forest structure across the site. This variability in structure supports the need for active management rather than just passive approaches. We recommend group selection to promote regeneration and structural diversity. This approach is implemented over a long-term timeline of approximately 100 years. requiring repeated management. An alternative approach is less intensive management, but this may limit regeneration and reduce habitat complexity over time. Hydrology management is a key component of this plan. We observe that altered water movement is limiting ecosystem function. These patterns are consistent with what is shown in earlier figures and site observations. We recommend removing or modifying levees to restore natural water flow and reconnect floodplain processes. An alternative is maintaining existing structures by restoring natural hydrology provides stronger long-term ecological benefits. The objective is to support restoration while providing financial return. We recommend a wetland reserve easement or WRE in short, which protects wetland systems while providing financial compensation to the landowner. These programs create a direct connection between ecological restoration and economic benefit. This can include up to a full easement compensation and significant restoration cost coverage for the landowner. An alternative includes programs like EQIP or CRP, which provide support for management practices but offer less long-term protection. These programs also support recreation and hunting objectives. This objective focuses on recreational value. We observe moderate browse and high habitat suitability across the site, supporting a healthy deer population. The data reflects consistent conditions that support long-term habitat use. We recommend maintaining forest diversity and understory vegetation. An alternative is minimal management, which may reduce forage quality over time. In addition to deer hunting, the property supports wildlife viewing and other low-impact recreational uses. The objective is to enhance pollinator abundance and diversity. We observe that existing vegetation provides some baseline habitat. Variation in plant communities suggests opportunities for targeted enhancement. We recommend maintaining native flowering plants, limiting disturbance in the form of invasive or non-native plants, and promoting understory habitat. An alternative is passive management, which may reduce diversity over time. Overall, this plan integrates forestry, hydrology, and conservation into a unified system. It restores long-term ecosystem function and resilience while supporting both ecological and recreational opportunities such as fishing, deer hunting. By aligning management actions with site conditions, this property can provide long-term environmental and economic value.